Here's a quick update video on the laser cutter project. So as you can see, I got all four of my motor drivers hooked up, the power supply block and the little interconnects out to the motors, or these little Phoenix terminal blocks. So I know this bolted down right now, but as you can see, the original connector is plugged right in and keeps everything nice and neat. Here we have our nice exposed 110 volts and my 24 volt 9 amp old Kepco switching power supply. So got all that wired together and hooked up and decided to do some testing. This little gizmo here is actually just a 5.5 timer. Originally I was going to use it to drive this. Unfortunately, the output on this is the off period, or the on period of this box is much greater than the off period, which causes this thing to do something a little funky. I think it's basically this thing, the pulses coming out of this are too slow for the hold current of this circuit to pick up properly. You see this work light blink, which is telling you when the work light's on, it's at full current out to the motors. When the work light's off, it's at the reduced current to the motors to keep, the heat in this and the heat in the motor down. So as you can see, instead I dug out my junk WaveTech signal generator. I literally pulled this out of a dumpster. So it was marked as defective, but for my stuff it seems to work well enough. Up here, I'm basically just using this guy for a 5 volt supply to run the direction bit and the enable. Turns out on this stepper driver, enable needs to be unpowered, or the input low, for the board to be enabled. So if you want to disable the board, you got to power up enable, which is a little backwards, or at least it's a little backwards to me. So anywho, I have this cranked all the way down, and if I sit here and dial down my frequency, and I'll explain why I'm doing that in a minute, and turn on my output, as you can see, it's starting to move up. And if I spin up the frequency here, haha, it works. So we got good movement out of it, and I didn't ram it into the end stop, so life is good. Now if I pull this wire out, which takes direction low, it will come back down. But if at 35 kilohertz I just enable the output, nothing happens. That's annoying, so let me turn that off. So what's going on here is at this frequency there is not enough time where the windings are on to generate enough torque to start the motor. So it's just sitting there doing this number between two steps really fast. So the way to get around this is acceleration, and to do acceleration I have to do it manually. So if I take this down to about 5 kilohertz, I think it'll start there. Close enough. And there it goes. Now you notice that horrible start. So let me take it down to 4 kilohertz. And even at 4 kilohertz, this is a pretty decent speed for the Z-axis. All this is going to be used is to adjust the bed to set the focus. So I'm not really too concerned about it. And if I wait a second here, got it. So now I just stuff this wire back in, and I can turn on the output and run it back up again. And I'll I can crank it up there pretty fast and it runs pretty smooth. And then this guy just has a belt between the two underneath that cover, so they're in sync, or at least I hope they're in sync. That's eventually at some point, once I find a piece of aluminum I can afford for the bed of this, I'm going to put a dial indicator on this and run it back and forth across the top of the plate, assuming the plate's flat. With that, I can sit there and disconnect the belt between the two sides and sit there and jockey it a few teeth and get everything perfectly flat in this direction. Same thing can be done in this direction using this axis, but to level that I have to put shims on here. And when I took this apart, I found a bunch of little copper shims. So I'm fully expecting this thing to be a little wonky, and I'll have to tune it up once I get that far. Let's do this one more time. So let's go down. And now let's go back up. And I want to see if I can get this thing to run over 40 kilohertz, which may be interesting. So I start out about 4. Let's go in the right direction. Oh, right there it died. So about 40 kilohertz. Once I hit 50, it lost step and locked up. I don't know what adding mass to this is going to do to the system. I assume it's going to reduce my top speed. Let's see if I can find out real quick. Unfortunately, you have to hit second and then this button to put it back in standby mode. That's kind of a bummer. I wish there was just one button that would go standby, just so you don't have to go mashing buttons anytime you speed this thing up and you start getting close to an end stop. So what do I want to do here? I want to start this and apply some mass best I can. I don't know how much of that buzz was because I was pushing down and how much was it I was smashing buttons and I probably hit something I shouldn't. You know what, I can just pull this clip off. Yep, that'll do it. That's my new plan. Give me the most time possible. Okay, so yes indeed, if I get this thing moving and then really push down on it, I can stall out the motors and cause it to go into that horrible squeal. So this is probably just a factor of the limited amount of torque I can get out of this motor at the currents that this stepper driver can put out. I did set up the current setting on this to 4 amps, which matches what the motor can take. I got plenty of power coming in this thing, so it's not like we're browning it out. Also, I'm set to 8 steps per pulse. So one way I can get more use out of the 40 kilohertz my PIC NC chip allows me to go up to is I can go to 16 steps. All these guys are capable of 16 steps, but I don't really know if that buys me anything. I have to do some more research on that. But for the most part, you know, for first movements, this is pretty damn good. So I drop this back down to, you know, worst case. Let's go even lower. Here's a kilohertz. I mean, I can stale this out, but I gotta put a decent amount of weight on it. So yeah, if I end up wanting to put like a big chunk of granite in here, this thing's probably not gonna, well, for lots of reasons this isn't gonna take it, but for us. Yeah, that might. So it looks like the amount of weight to stall the motors is not frequency proportionate, or at least not significantly. So I think I'm just running into the torque limits of these motors. You know, this thing was never meant to lift heavy weights. It was meant. Ooh, that's good. It was meant just to move the bed into position. Then you put your item in it and maybe focus it up and down a little. But you know, this definitely will take the weight of the bed and, you know, most normal things that someone might put on it with probably no problems whatsoever. So what's next? I gotta measure the pitch of the z-axis, because that's the one axis I don't have the measurements for. Second stop. I need to design up the little interface card that goes from the PIC-NC and the Raspberry Pi out to the motor drivers. I need to rework these drivers. They have some, depending who you believe and what you read, they have a nasty bug where the chip they use specifically states that 5 volts needs to come up before motor voltage, which in this case is 24, but they're using just a little LM7805 to regulate down from 24. So at best case they come up at the same time. Worst case 24 comes up before it. Well, it's ramping as the 5 volt is ramping. So some people claim that causes it to fry the controller chips. Also, this little cap here sets the internal oscillator. Apparently some of these cards have a design bug where they use the wrong cap, and it causes the decay settings not to work properly. So I got some caps to replace those if they indeed turn out the wrong value. So I got to rework these, but until I get the control cards, I'm not even going to bother. That's why I don't have any fuses in these locations. That's the other thing that all these cards, they say that they're missing, is a fast blow fuse on the input. So I can get 9 amps off of this guy easy. So I got 5 amps to this guy. I'm going to do 1 amp to the X, which is this little guy, because he's only a 0.6 amp motor max. And then this is for the Y, and this is for the rotate, which I have wired, but I don't actually have the unit to use it with. And they're both fused at 3 amps. This last fuse position, which is this cable right here, is going to supply 24 volts over to my control cards. They're going to mainly be powered off of 12 volts, which I need to get a 12 volt power supply and find someplace in here to stuff it. But I want the case covered that if for some reason that 12 volt supply blows up, dies, wire falls off, whatever, and this 24 volt supply is still up, it will keep 5 volts to these cards running even though the 12 volt domain is dead. Here's the front end of the Kepco. You got 110 coming in, 24 going out, safety ground, and this is the remote control. So if I short these two wires together, it will shut off the 24 volt supply. As you can see there, that red light went out, and then when you open them up, it turns back on. So I'm going to try and rig some circuit on this card with a voltage supervisor that watches the 5 volt domain out to these stepper drivers, so that if the 5 volt domain is not on and I'm not calling for 24 volt power, or I'm not calling for 24 volt power, this thing is shut off. Not so much to save power, energy, just to protect these as best I can. And then this little hole right here, I'm hoping I can cram the laser power supply in here. The 40 and 50 watts ones will fit no problem, but the 50 watt supplies are uber expensive, like $100 over the 60 watt supplies. Unfortunately, the 60-watt supplies, if I'd put them in there so the inputs are on this side, the outputs are on this side, so they make the corner go out the back, it's like a centimeter too wide. So they're all different sizes. I'm going through my options. I gotta figure out who I'm gonna buy my laser stuff from. But I'm gonna do all the movement stuff and some mechanical stuff to this thing before I buy that stuff, because that's gonna be a big mechanical nightmare across the back to get the laser tube mounts all set up and build a box around it and all that good stuff. So there you have it. It's alive. Yay. Just a lot more work to do.